Okay. Now we're going to switch over to the show and tell section of this. And I need to see a show of hands of people who want to show something. 1, 2, 3, 4, 5, 6, 7. Okay. Okay. And here's the deal. The audio in this room, if you're not wearing a mic, nobody can hear you. So we're going to be wiring you up with the wireless headphone mic. Or if you can do your presentation with just holding this mic, you can do that as well. Okay. So who owns this robot? Alan, why don't you start? Do you need the wireless or? Wireless would be best. So we have the wireless. Okay. Well, I'm sorry. I meant boom mic. Shut that up.
Can you hear me? Oh, that's good. Great. Hi. I'm Alan Fetterman. I wasn't planning to bring this till around 3 o'clock when we had a discussion about ROS, Arduino, and floorbots. And unfortunately, I don't have the ROS, Arduino all working together, but I do have the Arduino robot working. And the reason it's not all working is the Arduino under Ubuntu can't compile anymore. I don't know what I did. After the third successive Ubuntu upgrade, something happened to the Arduino sketch.
Do you have video?
Excuse me?
Do you have video?
Video of it working? Yes, I do have video of it working. I'm pretty sure, yeah. I have a couple of YouTubes of it, because I did this a couple of last year.
Not that we don't believe you.
So there is a sketch. This is embarrassing. The sketch is working because Arduino under Windows Vista is working, but it's not working under Ubuntu. So this is a track vehicle. This is a Goodwill find for 30 bucks. It's basically a pack bot. Every once in a while they come up. You can buy them at Goodwill, or I don't know if you can get them on eBay. It has it's a pretty interesting platform for those of you who want to experiment with floor mobility. It's just working off a small battery pack, so its range is limited. However, it's pretty powerful, and it has 4 motors in it. So it has a left side and right side which power the tracks, and then it has a forward and back spin the tracks. So you can get it to stand up on its tiptoes. You can put it into like a V configuration, so it can go up obstacles. I actually had it try to climb onto my sofa one time, which wasn't that good for the internal gears, so I had to replace some of those. So that's it.
Can it climb stairs?
It can climb stairs, but it takes a lot of coordination to climb stairs. Can't open doors though.
Up or down?
Down is easy. Up is hard.
Okay.
That's good now.
Oh yeah. Actually, down it just slides down.
Oh, it slides down.
Okay, let's see who's next. Okay, I see a volunteer here. I don't know it's you. Raise your hand. Let's bring it up here. And please stand behind the table here. Okay. We find it works better if we just put the mic on you. Put that in your pocket.
Testing. So So this is a table bot, and it's Lego Mindstorm. So we built it, and my sister will explain some of it to you. This is a table bot, and I programmed it, and my brother built it. The way how it works is it goes on the table, and when it goes to the edge of the table, if it's right center is pressed, it goes back and turns left. And if it's left center is pressed, it goes back and turns right. So this is a touch sensor. This is a touch sensor. So if it, right now the touch sensor is not pressed. So if it goes off the table, it'll get pressed. So it just goes back. So now I'll run the program.
Phase 1?
I don't know what phase it is.
It's fun though.
If it stays on the table, it might be phase 4.
It has low battery.
We're familiar about batteries. Violet helped out. Good.
Hey, phase 1.
Very good. We take the mic back. Okay, who do we have next? Would you like me to do it? Is Kentucky Fried Robot? Come on, let's bring it up.
I can bring it up.
He's going to explain. You got to come around to this side of the table. All the way to this side. Okay. He's going to put the mic on. Turn around. There you go. Let's see. That's it.
Testing. That one right here. Yeah.
It's okay. Don't worry about it.
No. There.
So explain to us what your robots do.
Hello? Okay. Testing.
Yeah, it's working.
Okay. This robot doesn't, the battery's dead right now. Doesn't work. But should go. Spin. This one you'll find the beacon. This one it will run on its own. This is stop. This is to control right, left, forward, backwards. I don't remember what those did. This one I think is demo mode. This one's sleep mode. This one's guard mode. And this one's game.
Okay, good.
And that one actually, I don't know what that one is. This one finds the beacon. What?
Yes, the battery should be recharged.
This one will go forward and then the light's right there. And When you press this, it'll pop out. You push this, push back in. Button right there, and the lights will light up. I'm going to show it right now. This one lights up right there, and it walks. I'm going to show this one also right now. This is the Arduino board right here, and this is the, what's this, Jay? Jay, what's this? Oh, SD card shield.
Yes, sure.
And this is the breadboard. These are resistors right here. I don't remember what this piece is.
Let's turn the robot on and see what it does.
These are wires right here, and there's a battery pack, servo, cork. Daddy just asked for the cork, and they give it to him. And Daddy just asked for this, and they give it to him.
Let's turn it on. See what it does.
Remember what he said. Okay, these are frozen. These are just ball caps. Okay,
Is this a floor bot or a table bot?
floor box.
Let's pull this out.
And
And it will follow the light if you point this light at it. It'll follow, I think, right. It's not doing it right now. Okay. It should at the moment. Now it's turning. It wants to turn to the other light. Yeah. Whoops, I'm going to turn it on.
Very good. Let's give a big round of applause. Thank you very much. So who do we have next? Camp, are you ready to go? Okay. You need boom mic or boom mic?
School gave more conviction. That one's doing good.
Test 1, 2. Hi. I've got Locomo, my smart table here. As you can see on the screen, it's a RViz, Ross RViz visualizer. The robot's over here in the corridor, and now I shall attempt to drive the robot. And it's kind of sort of making a map there, I believe. Now I really can't see where I'm going. Hopefully the robot's coming out now. How am I doing? Forward? Forward? Yay! So ideally you'd be in a much smaller environment and have some kind of shoreline to track there. I'm just remote controlling this, and you can see that it's made a little map there of the corridor. Let me, I guess keep going forward might be the best way to do this. So I'm going back. I'm sorry, what? Well, I can see now, so it's no problem. Hey, actually you should be staying in line, but I'm not. And I'm going to drive on down here. Tell me when to stop. Stopping. Okay. And again, you can see I'm kind of sort of making a map there. So eventually, one of these days, I'll be able to tell the robot where it is and its pose, and having mapped a room, point out a goal, and the robot will autonomously navigate to this goal. But that's where we are today. Thank you very much.
Thank you very much. Okay, I saw some hands go up earlier. Who's next? Shiloh, are you showing off that robot?
That's Tony's.
What?
It's Tony's.
It's Tony's. Sorry, misrepresented. It was Yeah, some people raise. What about the robots back there? Are we going to show those off? No? Okay, who wants to do some more show and tell? That's it? No, I'm sorry. There we go. Let's do. I don't know your name yet, but I'm going to learn.
What do you mean you call it?
So, here I go again, my micro mouse, which is being run by ATmega 128, and I am now learning ROS from the excellent Patrick's book, ROS by example. I thought maybe I can run ROS on this little guy. So now it runs ROS serial over Bluetooth to the laptop, and I have hooked it up to Arvis, and I will try to do some point and click navigation with Arvis. But I can see the coordinates of my micro mouse on my screen, and I can just click in Arvis and the robot will go to the point where I send it. Yes, it is just using encoders on the wheels and a gyro.
Are you running the navigations now?
No, not yet. But I hope by the next time I will use more of ROS. Okay, that's it.
Very good. Thank you. So are you folks ready over there? Yeah. Okay. So where's the camera's over here. Can we do the presentation up here? Okay. Which one of you is going to be mic'd up? Who's going to talk? You're going to talk?
Okay, testing.
Testing, testing.
So, I'm Rohan and this is Sid.
There's actually one more member of our team. His name is Maxime. He's not here today. So this is our team, and this is our team captain, Alex. We participated in this challenge called the Google Lunar X Prize.
We participated in the Moonbot section, in which we had to make a Lego Mindstorms robot. Here is the robot that we have. This is courtesy of a lot of help and a lot of Lego parts, and it's able to scale a very large moonscape, 6 feet by 6 feet. So that was a challenge, and as you can see, it has very high terrain.
So I guess we're going to show the video right now.
Okay, we're not hearing it. Okay, so I guess we have to re-narrate this. Plant which we're collecting from.
Alright, good job.
Taking picture of the
The entire thing is autonomous, so it was a challenge program.
Alright.
Taking picture. Going back to base. But maybe scaling the ridge. Accidentally made it. Off the ridge.
Alright.
Come back to the base. Going back. Then in the back. Back to the base. It's back to the base. Going down the ridge. Going on the ridge. And it did it!
This was our robot run, and this entire moonscape was designed by us. It's not like they gave us a game plan. All they said is you need to have this ridge in the middle, and you need to have a robot. We kind of had to do everything ourselves.
Yeah. We were provided with some of the stuff in our robot, like we were given a solar panel. Like some of the stuff was given by the people who conducted the challenge, but then most of the stuff like the robot and the landscape and the mission, like the landscape and mission are completely ours. Like some competitions, they like tell you what to do, and they give you like a certain like mission where like if you do this you get this many points. Well, over here we made our own mission and our own points and everything, so we can design it however we want it.
Yeah, and most teams use Lego for this. We decided we already have a Lego robot, so we made our thing out of wood and paper mache. And the communication station that you saw earlier, because we as HBRC members make robots with raw materials and like microcontrollers and stuff. So we applied our knowledge, and we just had to use something, some Arduino in here. So we made a communication station with the Arduino and an XB to communicate with the Earth, which has a small LED on it. So if it doesn't work, you can't tell. And we have those lamps right next to it because the solar panel, it doesn't collect enough solar energy if we don't do it. So we just put a couple of lamps there.
Also, our robot, it has the design is pretty it's pretty good because as you can see, first of all, most. Wait, let me keep going this. So so you notice how the motors are on the top. The motors are on the top, right there. Most robots had it on the bottom. So we had multiple versions. So this was our first version. As you can see, the motors are on the bottom. But then our robot started having imbalances in its design, and the gear started cracking, and it started getting really severe that pieces of plastic started splattering all over the place. So we just thought we needed to drastically change it, not just move an axle or something. So
also the problem with the motors is that that ridge is 6 inches high. We have a ramp and we have all sorts of bumps and craters. So if you have these oddly shaped motors there, if some bump comes there, it's just gonna get stuck, and you're gonna have all sorts of issues.
And then the next thing is one of the common things that all our robot designs had from the beginning is we used this design called the rocker buggy system. As you can see, the wheels. Front two wheels move on their own freewheeling axis. So the captain said, all Mars rovers such as Curiosity, they use this system for traversing over rocks and ridges and craters and stuff like that. So we decided, well, this isn't as different as Curiosity, except it's made out of Lego and it's not actually on Mars, and it's only, and plus it's not
and it has a differential drive on it.
Yeah, and it's not $1 billion. So, yeah. So this, yeah, and then plus this thing has Omni wheels that were provided by a company called Rotocaster. So they were really helpful.
The reason why we needed these Omni wheels is because we have a nice 6-wheel all-wheel drive. So if you try to make a nice narrow turn, the outer 4 wheels, they're going to start dragging, and you're going to get some turning problems. So these Omni wheels really helped so that we can make really tight, narrow turns, which kind of eases the robot programming compared to if you have to take really wide turns. Yeah, you have to make sure you have space, and it's hard to calibrate.
And, oh yeah.
Yeah, can you tell us how you localized yourself on your landscape? Because you were steering around pretty accurately there for Lego robots.
Well,
how you did that?
So first of all, some of it is just raw, and we have a couple of sensors.
We have some color sensors, and we used to have black lines, but then these color sensors have the problem when you go up or down, they sense black. So we kind of cheated and made them green lines, so that helped. And also we have an ultrasonic sensor that we use to localize ourselves, and the rest of it is really hard fine-tuning. Yeah.
All right.
Yeah.
Excellent. Thank you.
Okay, do we have any more robots for show and tell? If not, what we're going to do is we're going to do a 5-minute break while I set up for the talk, because I'm the speaker tonight. And the talk tonight is about surface mount technology. The title is for roboticists, but it's basically anybody who's doing hobbyist, prototyping electronics. And just so you know, I have a show and tell tonight, but I'm going to do it after the talk. Are you ready for us? Okay, so we do have one more show and tell.
So, yeah, I'm not going to be showing how it works because it doesn't. Okay, that's better, right? So this is my Magellan robot. I had a lot of problems with every single component, but now they're all fixed and everything works, I hope. There's no software written for navigation yet at all. I just fixed up the GPS and it works. Kind of. But yeah, that's all that I really did. Also, I am in the process of writing an article for the Servo magazine about the Nito robot and how to use the IR sensors on the bottoms. And if you ever wrote an article and have any tips that you can offer me, or just tell me, please do that. That'd be awesome. Okay, great, thanks.
Just a word for the wise. Sometimes they're a little late on paying up for the article, so you might have to ask again. Okay, so what we'll do is we'll take about a 5-minute break, okay, and then we're going to go into the main talk, which will be surface mount technology for roboticists. Okay, thank you very much. 5 minutes.